Next question, functions. F of x equal to x by root of 1 minus x square. G of x equal to x by root of 1 plus x square. Then f circle g of x is. F circle g of x can be written as f of g of x. But g of x is defined x by root of 1 plus x square. Now the definition of f of x is x by root of 1 minus x square. But don't write x. First write the remaining part except x. Okay, but x is here, x by root of 1 plus x square. So in the place of x, substitute this part. So x by root 1 plus x square, x by root 1 plus x square whole square, because it is x square. So whole square. Square root cancelled. So x upon 1 plus x square under root, and denominator root is cancelled. So take LCM, 1 plus x square minus x square by 1 plus x square, it is under root. X square is cancelled. So x by root 1 plus x square by root 1 is 1, 1 plus x square under root. These two are cancelled. X is the answer. Next question. Let x not equal to 0, mod x is less than 1 by 2, and f of x is 1 plus 2x plus 4x square plus 8x cube plus so on. 1 plus 2x power 1, 4x square is 2x whole square, 2 cube is 8, so 2x whole cube plus so on. This series is in GP with the same ratio. So it is in GP up to infinity terms. So sum of infinity terms in GP formula we can use here. So sum of infinity terms in GP is a by 1 minus r. A is the first term, 1 minus the common ratio is 2x. So this is the function f of x. So f of x is 1 by 1 minus 2x. But here we are going to find f inverse of x. So to find f inverse of x, first f of x, let f of x equal to y. F of x equal to y. So y equal to 1 by 1 minus 2x. From this, just simplify and find what is x. So 1 minus 2x equal to 1 by y. Do cross. Just taking down y down. So minus 2x is 1 minus 1 by y, which is equal to y minus 1 by y. Then x equal to y minus 1 by 2 goes down. So 2y. So this is x value. X is y minus 1 by 2y. So after getting x, you can write directly f inverse of x. F inverse of x is x minus 1 by 2x. So this is f inverse of x. X minus 1 by 2x. Because f of x equal to y means x equal to f inverse of y. So x means it is equal to f inverse of y. So f inverse of y is defined in y means f inverse of x can define it is in x terms. Next question. The domain of root over x minus 3 into x minus 7 is. So to find the domain, it is in under root. So under root f of x, its domain means input values. F of x must be greater than or equal to 0. Okay, under root negative number is not defined. So for root f of x must be greater than or equal to 0. In the same way, given f of x is root over x minus 3, x minus 7. So here under root x minus 3, x minus 7 must be greater than or equal to 0. Okay, for this the answer is x belongs to x values. This is 3. 3 is a small number and 7 is the big number. So minus infinity to 3 union 7 to infinity. For infinity always open bracket, and here equal symbol is there, greater than or equal to. So take closed bracket for 3 and 7. So x minus alpha, x minus beta greater than or equal to 0, and x minus alpha, x minus beta less than or equal to 0. For this Suppose take a number line minus infinity to infinity. Here also the number line minus infinity to infinity. Here alpha beta, locate alpha and beta. Here locate alpha and beta. Okay, if the expression is greater than or equal to 0, then the roots does not lie between, x values does not lie between the roots. These are the roots, alpha and beta are the roots. Okay, if x minus alpha into x minus beta greater than or equal to 0, the x values, the domain must not be lie between the roots. That means the values of x lies between minus infinity to alpha and beta to infinity. Okay, suppose if the expression is x minus alpha into x minus beta less than or equal to 0, the x values, the domain must lie between the roots, So x belongs to alpha comma beta closed brackets. So here the answer is minus infinity to 3 union 7 to infinity. For 3 and 7 take closed brackets. Next question, the domain of real valued function f of x equal to root over 6x square plus 5x minus 6 upon root over 4 minus x minus of root over x plus 4. Okay, then these are the options. So here there are three roots. Okay, and I already explained about root f of x function. So function is in terms of root f of x. F of x must be greater than or equal to 0. Suppose if it is in the denominator root, and f of x must be just greater than 0. Okay, here there are totally three different functions. 6x square plus 5x minus 6 and the root part must be greater than or equal to 0. But here two more functions are there. Those are 4 minus x and x minus 4. Anyway, these are two things are given in the denominator along with minus. So the second thing, denominator 4 minus x, so that must be greater than or equal to 0. And one more function is there, x plus 4 less greater than or equal to 0. So the common solution is the domain, the common solution. So 6x square plus 5x minus 6 can be written as 2x plus 3, 3x minus 2. These are the factors for this expression. So greater than or equal to 0. Okay, if the expression is greater than or equal to 0, the x values must not lie between the roots. So it starts with infinity, minus infinity. So here the solution is minus infinity to, and here the small value is minus 3 by 2. 2x plus 3 equal to 0, then x is minus 3 by 2. And here it is 2 by 3. So minus 3 by 2 is the smaller than 2 by 3. So take first minus 3 by 2 and closed bracket because it is equal. Union, here one more root is there, 2 by 3 to infinity. So this is the solution for the first expression. Next, 4 minus x greater than or equal to 0. X minus 4. If you multiply with minus, sign changes. So x less than or equal to 4. X less than or equal to 4 means the x values must start with the least number minus infinity to 4. Minus infinity to 4. For 4 take a closed bracket. For infinity always open because we can't say the exact number. So x plus 4 greater than or equal to 0 means x greater than or equal to minus 4. So here the interval starts with minus 4 to infinity because x is greater than or equal to minus 4. So the minimum value is minus 4. Take closed for minus 4. For infinity always open. So the combined answer we are going to take here. Take a number line minus infinity to infinity. Here the roots are minus 3 by 2, 2 by 3, 4, minus 4. So minus 4, minus 3 by 2, 2 by 3, 4. Okay, just look at these roots. And first interval says minus infinity to minus 3 by 2 and 2 by 3 to infinity. And the second function says minus infinity to 4. So take x values only from minus infinity to 4. So minus infinity to 4. Okay, and the third function says x belongs to minus 4 comma infinity. So start from minus 4 and up to infinity. So the common solution will be 4 lines here, 4 lines. So this is the common solution. Common solution is minus 4 comma minus 3 by 2 closed brackets, because here also for minus 3 by 2 closed, for minus 4 also it is closed. Union, one more interval is there, 2 by 3 to 4. So this is the domain of the given function, the common domain of the given function. So the answer is first one. These are the given options. Next one, the domain of logarithmic function. For log function, log of f of x, the f of x must be greater than 0, just positive. Okay, so log of 25 minus x square. So here 25 minus x square must be just greater than 0. So x square minus 25 multiply with minus both sides, then it will be less. So sign changes. So it is x minus 5, x plus 5 less than 0. Less than 0 means the domain lies between the x values, lies between the interval. So x belongs to nothing but domain. So here the two roots are minus 5 plus 5. So minus 5 to 5. And here there is no equal, just less than. So take open bracket. So x belongs to minus 5 comma 5 is the answer. So the first one.